large parts, and particularly building large parts from expensive materials like metals. Now, metal printers are now becoming more and more common, but there will be a time when you cannot use powder bed systems for building really large components. Give you an example. Maybe I need a bit of translation into Indian rupees, okay? But if you think about, for example, the larger metal powder bed printers, so the biggest ones there are some bigger ones, but the biggest ones that are really generally available, about 500 millimeters by 500 by 500. If you wanted to print a large 500 millimeter high part in titanium, you would need around about 300,000 US dollars worth of materials just to fill it. So what does that come in rupees? 2 crores. Okay, so that's a lot, yes? So you buy a machine for about $1 million, well, for those machines they're closer to 2 million US dollars. And if you then have to add on to that another approximately 20% in cost in the materials alone. Okay, so if you want to build really big metal parts, then powder bed is not the way to go. Anyway, I'm moving away from. Let's see what else, and then I'll talk a little bit more about bioprinting in the form of looking at devices, because tissue engineering is definitely a way that we are going. Okay, so I've said that it's a difficult problem, and it certainly is. I've said that there are people working on it, but they've got a long way to go. That's absolutely true as well. But that doesn't mean that we don't see where this is going in terms of, say, being able to create complex soft tissue organs in particular, or even bones with the cartilage attached, so that we can make articulating joints and surfaces. So people are definitely working towards that, but it's going a long way. And in fact, just to give you an idea, I know a lot of people that have been working in bone tissue engineering for many years. I've been working on it for quite a number of years. And our objective was always to try and create bone implants, artificial bones. And more recently, we kind of stopped. A lot of these people have stopped doing that. Because what they've realized is that there's a lot of knowledge that still needs to be gained just in the process. So instead of talking about creating bone implants, particularly we were looking at load-bearing bones. So skull plates we've been doing for years, but other, say, particularly hip joints and things like that, we've been trying. And what we found is that, okay, that is a long way to go, particularly since the cartilage region is extremely difficult to replicate. But the knowledge that we've gained during that process has helped us to develop models which we're looking at, say, drug devices in particular, looking at treatments of cancer, creating three-dimensional models which can then be treated in vitro, outside of the body, in some kind of controlled environment, and so that we can study the effects, how cancer grows, how different treatments impact that in a three-dimensional manner. And so a lot of people have been working, now switched to looking at those rather than trying to generate load-bearing bones themselves. Been a bit of mention about food printing. I'll say something about that. I'm not a big fan. We'll look at the implications relating to design and manufacture. Then some other stuff, related technologies. We'll look a little bit about health monitoring devices. Why? Okay, well, two reasons why. One is because a lot of health monitoring devices can be customized or could be customized so that we can effectively monitor, and this is probably looking at medical conditions. People that have particular medical conditions, they need a health monitoring, a sensor located in a particular place, so we customize them. The other side of it, and so therefore 3D printing is useful for customization. Okay? The other side of it is, and it's been mentioned very briefly this morning as well, is about certification, approvals, ethical approvals. Whenever you're going to do anything related to medical, it is a lengthy and difficult process even to get the documentation done. Okay? Rightly so. Okay? It's not that, you've got lots of documents, I hate doing these documents, I'm not going to do this, But the thing is that you've got to make sure that you've thought of everything in any experiments that you're going to do, particularly if they're directly related to the human body. Interesting thing, however, is health monitoring devices aren't so regulated. So if we're talking about monitoring in particular rather than treating, then the barriers are a little lower, and sometimes that you can get a lot more information a lot more quickly in this route, in this direction. Still quite a lot will be related to ethical approvals and things like that to ensure that all your subjects know what it is that you're doing and stuff. But it's a potential area where it could be beneficial. So health monitoring devices. What else we'll be looking at? Rehabilitation aids, assistive devices. I did been doing a lot of work in particular in relation to trying to help the elderly. And 3D printing is a great technology to develop prototypes and to develop specific solutions to a problem that one individual person is experiencing. So, if you've got an elderly person and they've got rheumatoid arthritis and they can't open bottles or whatever, then you can quite quickly develop a device which will help them to do that. Or they've got movement in one arm but not the other, and therefore a device to grip food while they're cutting it and stuff like that. So this kind of thing is quite common. Dentistry. There's an awful lot of 3D printing in dentistry. Ravi mentioned about how medical devices, our medical industry is the third most important technological or field for additive manufacturing. And the main reason behind that is actually because of dentistry. And matter of fact, the most profitable application area as well is dentistry. We'll cover that in a bit later. We'll cover a little bit about business, a little bit about cosmetic surgery, a bit about sports technology, and a little bit about drug delivery devices. Drug delivery devices, what I mean by that is controlled drug delivery, 3D printing of drugs. And what else? Okay, so again, what we might do at some point is we'll try and brainstorm. Does anybody think that there's something missing that they wanted to see? Anybody? Raise their hands. Fish? You want to see about tissue? Okay, so we will cover tissue. Okay, what else? Anything else? Sorry? Heart valves. Okay. Yeah. Well, let me see what I can find. I'll have to have a look at that. Catheters, yes. I'll see if I can find some examples there as well. Some of these things, 3D printing of heart valves, interesting issue. One might ask why, or if you're wanting to go that direction, why are you going that direction? There are artificial heart valves designs. I have half in agreement and half in disagreement with some of the work in that space, because heart valves, just wondering about the actual 3D printing processes. Yeah. Okay. Anything else? Printed surface coatings. Ah, okay. We'll talk a little bit about post-processing in some of the application spaces, but that's a very good one. Interesting, and we might, I might at least maybe just have a bit of a discussion about that. Porous structures, yes, we'll have that. Reverse engineering is basically the scanning and the software, so yes. Good. Right. Yeah, we'll cover that a little bit. Yeah, it's essentially post-processing, but it's very specific. You're right. So sterilization and other potential contamination issues we should cover. Particularly, for example, if you're metal printing, how can you be sure that you've got rid of all of the powder? So, an interesting issue. Yes, good one. Yes, sir. Yes. Yes. Absolutely. Yes. Yes. Absolutely. So when I cover the section on 3D printing, I will try very hard to cover that. We'll not be able to cover every aspect of where it might be useful and not, but it's a very, very good point. There is a sort of, again, people in the in the wide world think that it can do everything, and you're absolutely right. It's got significant limitations, and these days we look at process chains more. In the past, we had this tendency to say, oh, we can replace an entire process with just one printer. And that might still be a goal and might still be possible many years in the future, but certainly not now. And nowadays, because I find myself in particular working very closely with industry and talking to companies about what are their objectives and what are their goals, and they need more specific answers. In particular, about how can they, or what do they need to change. So these days we talk more about change management and process planning and Industry 4.0 and other factors which basically are trying to say it's not just about the machines, it's not just about the materials, it's also about the processes, it's also about the data, and everything all combined together. And so there we explicitly say, okay, if you buy this machine, it's going to give you a surface roughness of some value. And if you need a better surface roughness, then you need to have some kind of polishing or grinding or finishing process or coating processes in order to overcome that. So then you say, well, okay, do you have those machines already? If not, then that increases the level of investment, because that's what they're looking for. They're wanting to know what it will take to build up a workable facility for their products. And that is true in the medical devices arena as much as it is in any other. Okay, so just in the last few years, medical device company, you've heard of Stryker, yes? They make implants. Okay, one of the largest implant manufacturers in the world. And they are probably now becoming, or rapidly becoming, the biggest 3D printing company in the world, because they've just installed a facility with something like 150 metal printers in Ireland, creating hip implants using 3D metal, powder bed metal printing. And in fact, one of the interesting things about this is that the hips that they are printing are in a standard line. They're not customized. Okay, so there's a range of sizes according to their standard line. But they use 3D printing because they realize that it's the most, actually I think they use 3D printing for two primary reasons. One is that they say, the reason they say is that it's the most appropriate technology to use for building implants because of the complexity of the geometry, the fact that you can create a relatively rough or even porous structure, which is good for osseointegration, for bone ingrowth. I think the other reason, which they won't say, why they use metal printing is because they're creating their in-house expertise. They're creating in-house knowledge on how to do 3D printing and how to go through, and they're going through all of the problems because they want to be the first to be ready when it is actually possible to do customized metal printing for implants, which is not currently possible at the moment. Now, some of you are saying, hang on a minute, of course you can do customized metal printing. There's people in this room who have already done it. But what I mean is through a standard procedure rather than a specialized procedure. And what I mean is that it becomes a treatment plan that medical insurance companies, that hospital authorities, medical authorities accept as a standard route for treatment. the moment, that isn't possible hardly anywhere in the world. Okay? I'll explain again a little later about that if it becomes confusing. Okay, good. Thank you very much. Let's see. The future. I think what I'd like to do, and we'll do this as a bit of a tutorial type session sometime later in the week. We'll do a little bit of an exercise, get you talking as groups and thinking about how would you set up a 3D printing business for healthcare. Okay, so prepare yourself for that. Okay, so I'm not going to be just standing in front of you as the lecturer in front of you. I'm going to actually ask you guys to do a bit of work at some point. And I don't mean the exam. Okay. What I mean is that I'd like you to actually speculate and look to the future about where this industry is going. Okay? I'd like you to then work it maybe around yourself. We'll maybe I'll give you a bit of a framework about how to do this. And it's quite a big class, so it's going to be a bit tough. But maybe we'll take a couple of hours out during the week sometime, and we'll see what maybe some of the groups have found out. Okay? So prepare yourself for that. And we'll do that in the form of a SWOT analysis. Look at where the strengths, weaknesses, opportunities, and threats are for a particular business venture. Okay? You want to do that? Yeah? You can be the expert. I'll get you in as a judge. Okay? You've done it? Who said this? Oh, yeah, sorry. You've done it in your industry? Yeah, I mean, most companies have to do it. Yeah, it's an important thing to do. But these guys might like a little bit of practice, all right? And if you get some really good ideas, then you talk to this man, and he might help you set up a business. Okay. And we'll also look at it in the constraint space around this, okay? Because particularly in the medical device field, so you might want to say, okay, I'm going to look at maybe health monitoring devices because, as I've already said, it sort of moves around some of the regulatory processes, okay? But you might then also say, well, I actually want to treat people. So if you do that, you've got to get yourself around, you know, how the healthcare systems deal with this, governments, insurance, how it might relate to intellectual property, and also how you might be able to get funding. So these are things that we might like to just have a bit of a discussion about. Because all you students, okay, how many of you are looking to then become academics, that want to become faculty? Or have you had enough? No? You don't want to do it? Some of them do? Okay. Some of you do. Okay. Brave guys. Okay. Okay. Prepare yourself for a life of poverty. This is going to be the areas that you guys are going to be working, particularly if you're in engineering. All right. Now, I kind of, I kind of think that particularly in engineering academia, we move between the sort of the fundamental and the application space. You actually need both, really, from an engineering perspective. And therefore, your teams, and this is another thing, will need to have certain aspects of both. But it might be interesting then for you to sort of think about what it is that you're getting yourself into in trying to develop, because a lot of the ideas will come from engineering, okay? And a lot of the ideas will then, hopefully, a lot of those will turn into businesses. I was talking to somebody yesterday who was saying that this is something that is, he was a lecturer at an institute in India. He's not here. But he was saying that this is something that they're struggling with at his institute. Yeah. So he was basically saying that he thinks that there are a lot of great ideas in his institute that don't go anywhere. And that's true in many, many research institutes, probably all of them, in fact. Even to talk about MIT and Stanford, those institutions, there are probably still a lot of ideas that don't see the light of day. Okay? But a place like here, like my institutes, that I've worked in, you can think that there's lots and lots of ideas, and nowadays universities are starting to become aware of this and trying to set up incubators and business development units and things like that. But we're really only scratching the surface. And I think that the future is development of universities is going to be a lot in that way. Because education is becoming less of a critical problem because of the internet. Nowadays, education is less about knowledge and more about understanding. It's less about where and how you get that knowledge, because you can get it in many places. But validating that knowledge, to know that it's right. There's a lot of rubbish out there. What a certain gentleman in America calls fake news. And there's a lot of... so our job as academics have changed into more of a guiding principle and trying to sort of give people guidance and encouragement and support in trying to explore new ideas. Yeah, so this is going to be also this is partly what GIAN should be about as well. So the important thing, therefore, is to travel a road together. I've no idea where this road is, by the way. It's just Shutterstock. It's not, the highest hill in the Netherlands is 120 meters high. It's the flattest country in the world. Most of the country is underwater, okay? Or under sea level, rather. So it's definitely not the Netherlands. But so I can tell you where it's not, but I don't know where it is. Maybe it's India, huh? Is there somewhere? No. Anyway, the important thing is that we do this as a team, or you build your teams and work together. And so this is also my job as well, to try and sort of help with some of that guidance. So how much time have we got? We're 20 minutes? So I won't start the next one. I think we should just break here. But before we do, questions. Anybody got any comments, questions, thoughts, ideas? Sorry? What about customization? Yeah. We will definitely cover that. It's really the major reason. I sometimes label additive manufacturing or 3D printing in terms of 4 market sectors. So I say one market sector is characterized by aerospace, another by the automotive industry, another by the medical industry, and the 4th is what I label as entrepreneurial industry. Okay. Aerospace Why? Because of the complexity of the geometries that we are able to create.